Hello, Andre. This is Jack Crane on my assignment one submission for GAM-370 or graphics. So I'm starting with question two because question one was a little bit easier to explain. As you can see, there's the shape. So for my automated vertex buffer, I just do a vector array called vertices that takes in the num_verts, which is the constant you gave us, which is 12. And then I multiply I create it using this function, build n-sided polygons, which I'll get into in a second. Then I just for the byte width, I just multiply the size of the vector times the number of vertices. And for the indice buffer, I create a constant ratio, which is the number of vertices minus 2 times 3. This eventually leads to 30, which is the exact amount of vertices. Numbers minus 2 is 10. There's 10 triangles times 3 is 30, so 3 vertices for each triangle. Then I create a word array called indices that takes in ratio as its size. And then I have another function called build triangle indices, which takes in the size and the indice array. So I'll go to the definition. So for the build n-sided polygon function, I have two floats, two angle floats, and a radius float. I just set radius to 0.5, and angle 2 is equal to pi divided by number of sides. And then the for loop, for this for loop, it creates a new angle for angle 1 by multiplying angle 2 times the index times 2, and then I just for each vertice I set the x, the y, and the z based on these calculations. For build triangle indices, I have a count and a word temporary. This simple for loop, which for every 3 arrays, it counts incrementally, but on the third array index, it sets that index to 0, sets the count back to 0, and decrements the temp, which should go, since it increments every 3, it'll go back to the correct number, which would be 0, 1, 2, 0, and then 2, 3, so it'll go back to 2. And then I think that's it. Oh, and then I just do change this. It's the same as the ratio, but just to make sure there's 3 indices for each triangle. Okay, so now I'll just show you the other one, and this one was all hard-coded, so it's so much easier. But there's the star, 6 triangles, each with 3 vertices, 2 for the square, and source code. As you can see, once I get to it, I just hard-coded everything for the vectors and then did the according multiplications. I did the same thing for the indices. For your questions, so for this demo, it has weird behavior because it's calling the vector. In the rendering pipeline, clipping and rasterizing occur towards the end, whereas the IA and VS stages draw the whole shape. The IA and VS stages draw the whole shape, but clipping and RS stages apply the camera to the NDC. And since the NDC range for Z is only 0 through 1, 2 is out of range, meaning that it will get clipped and backface called, which causes the trapezoid shape when you input the value 2 for the top vertex. For the top vertex's Z value. For the second question, experimenting with different values in the top left, I thought it might be useful to render something else than the full window because you can mimic different resolutions for different devices, and also if the viewport range is too high, you might lose. If the range is too high, you might lose the object you're trying to render altogether. So it might be useful to render it in a different window. For the third question, the format in plain language is that the uint format is the R16 uint format is a single component 16-bit unsigned integer that supports 16 bits for the red channel. The other format is a 4-component 32. The R8, G8, B8, A8 uint is a 4-component 32-bit unsigned integer that supports 8 bits per channel, including alpha. Unorm means unsigned. Unorm means unsigned normalized. An unsigned normalized int, and uint means unsigned integer. Sint is signed integer. For the last part of this question, I wasn't sure what the channels meant, and I was unable to determine why the two formats were used. I didn't understand what the channels had to do with it, and yeah, I'm already out of time, so I will stop it there.